Hello everyone, thank you for joining me. I'd like to continue our discussion on OSPF and introduce multi-area OSPF and summarization into our discussion. But before we do, I just want to cover a couple things. You may have noticed that I've changed the topology again. I really wanted multi-area OSPF to stick. So to do that, I expanded Area 1 to include more routers, and I've also introduced Area 2 into the topology as well. I've also modified the VLANs in the access layer. So we have 4 VLANs now in the access layer that are connected to Area 1. And we have 4 VLANs connecting to Area 2 on the other side. Now, before we actually get into multi-area OSPF and summarization, I just want to do a very quick recap of where we are so far. So in the previous video, we configured router 1, router 2, router 3, and router 4 to form our Area 0 backbone, okay? We have adjacencies between 1 and 2, 2 and 4, 4 and 3, and 3 and 1. Now, I want to make something extremely clear, that for an adjacency to take place in OSPF, these 4 criteria need to be met. So the area ID needs to match, and which is set under the network command that we reviewed in the previous video. The hello and dead intervals are usually set to their default values. However, it's important to know that an adjacency will never come up if these 2 values have been tampered with in some way. The stub flag also needs to match. Now, for all intents and purposes, when we went to configure the adjacencies, for example, between 2 and 4, the criteria from 2 to 4 was already set for us, okay? So all we had to do was type in the network command and it worked. Now, what happened is that once 2 and 4 were properly configured to form an adjacency on this link, it began sending hello packets. And these hello packets are sent between router 4 and router 2. What happens during that particular process is that the adjacency moves down towards these 7 states. The router begins from the down state to the init state to the two-way state. Then it goes to the start state, the exchange state, the loading state, and the full state. It's important to know that the first 3 states is associated to neighbor adjacency, and the last 4 are used to synchronize the databases of the routers. Now, a router is considered to reach a two-way when it sees its own IP address in the hello packet of its neighbor. So if router 2 sends a hello packet to router 4 and router 4 notices that inside that hello packet he sees his own IP, that means that the relationship has reached the two-way state. Now, when the routers are in full state, which we've seen before in this circumstance right here, we've seen it here, show IP OSPF neighbor, full state. What the full state means is that the routers are fully converged and operational. This is a very important point, okay? Very key to understand. What we also talked about is we talked about how OSPF calculates its cost. Now, how does OSPF calculate its cost? By using the bandwidth. And usually the value that it uses is 10 to the 8. But this can be modified by modifying the cost of the reference bandwidth command under the OSPF routing process. And we went through that in the previous video. All right, so let's go ahead and look at my configuration for Area 1, this area right here. As you may have noticed, we go through the exact same process as we've done in the past. We need to configure the interfaces and we need to lay the foundation for any interior gateway protocol to operate on. So I've decided to do things a little bit differently, okay? First off, I decided to choose the subnet 172.16.32.0/24 for Area 1. Then I carved out 4/30s and applied them on the appropriate interfaces as indicated here. Okay? Now, I've applied the appropriate network commands as well. If you take a look at the OSPF configuration, so I'll just switch over here. All right, I've applied the appropriate network commands referencing the interfaces I want the OSPF adjacencies to be established on, and built out our first OSPF area, or our first multi-OSPF area, area 1. This configuration has also been applied on the routers. Now, moving forward, let's take a look at the IP OSPF database on Acme Core 1, and we'll see something very interesting. So, show IP OSPF database on Acme Core 1. Okay, so what's interesting here is that Acme Core 1, all right, which is this router right here, is a area border router, meaning it has an interface in area 0 and it has an interface in area 1. So what this means is that he maintains two separate OSPF databases. Okay, you can see area 0 and you can see area 1. They are one database and the second database. Okay, since he synchronizes his database in two different areas, he is eligible to obtain LSA Type 1 updates from both areas. So his routing table will recognize the routes originating from these two areas as O in the routing table. And to confirm that, we'll take a look at this. Show IP route OSPF. As you can see, the 172.16.0.0 network, whether it be the 8 or .12, pertain to area 1. But because he has an interface in area 1 and is eligible to obtain LSA Type 1 packets, he identifies these prefixes as O in the routing table. The same rule applies for the prefix 10.100.100.0, which is what we use to build the area 0 backbone. As you can see, he has and is eligible to obtain the LSA Type 1 updates and therefore recognizes these prefixes as O in his routing table. However, if we concentrate on this particular area border router right here, area 1's border router, the story is a little bit different, okay? Now, because this particular area border router does not have any interfaces in area 0, he only has interfaces that pertain to area 1. So the only LSA Type 1 updates that he will be receiving are the ones that pertain to the area he's participating in. So let's just take a look at the routing table of area 1 border router. If I do a show IP route OSPF, we can effectively see that the only intra-domain routes, the LSA Type 1 routes that he's learning, pertain to the prefix or the subnet that he pertains in, the 172.16.32. He is, however, receiving updates of packets of the 10.100.100 network, which is the prefix that we use to build out area 0. But these routes are now being tagged as OSPF inter-area routes. And here is where we start introducing the LSA Type 3 packets. LSA Type 3 packets are packets that allow the areas to update themselves of prefixes that pertain to two completely different areas. So under this circumstance, because area 1 does not have a link to area 0, he's recognizing the prefixes in area 0 as inter-area routes. Now, this rule holds true if I was to go to Acme Edge 1. If I go to Acme Edge 1 and I do show IP route OSPF, the opposite effect happens. The only LSA Type 1 updates that he's receiving are the ones that he's participating in, the 10.100.100 network. But for the 172.16.32 network, you can see that they are identified as OSPF inter-area packets. All right? The only router that is eligible to receive LSA Type 1 packets from both areas is Acme Core 1 or Router 3. This particular router, because it's the area border router, receives LSA Type 1 packets on both areas and therefore recognizes the 10.100.100 network as an O, as an intra, and also the 172.16.32 as a no intra. Now I'd like to go back to the IP OSPF database table on Area 1 border router and also the Acme Edge 1. So if I go to show IP OSPF database, what's interesting is that these LSA Type 3 packets are being advertised by the area border router. As you can see, the 10 prefix, the 10-100-100 prefix, again, which was used to build Area 0, is being advertised by the area border router. This happens to be the router that has eligibility to receive LSA Type 1 packets from that area. And the same holds true with Acme Edge 1. If I do show IP OSPF database, you can see that the 172.16.32 network is also being advertised by Acme, the Acme Core 1 router, which is the area border router. Okay, so this is very important. Now, the one thing that I'd like to mention is we have to introduce scalability into this equation, because if I was to add another 10 routers into area 1 and another 10 routers into area 2, what would we effectively see in the OSPF database of area border 1 router and the Acme Edge 1 router? Well, we would see the LSA Type 3 packets begin expanding, okay? You will see a lot more entries into the routing table, okay? And essentially that hinders the efficiency of OSPF when it's trying to look up best paths in the network and try to converge as fast as possible. So we try to summarize as best we can when we're dealing with OSPF, all right? So for all intents and purposes, I'd just like to show you how we summarize, all right? So from the 172.16.32 network, okay, I'm using 4 subnets, all right? However, if you take a look, and I want to just focus here for a moment, all right, this is the block that I'm using. So I took the 172.16.32 0/24, and I'm only using 4/30s from this prefix, all right? However, there is more room for expansion. So if I wanted to add more routers to this, I can. So what I'm going to do as a preemptive task is I'm going to go on to the Acme Core 1, this particular router here, and I'm going to run the following command. And I'm going to go config t, and I'm going to define the range. I'm going to define the range okay, of 172.16.32.0. I'm going to define that range, all right? Now, what that's going to do is, and I might as well also do the router OSPF 1, and I'm going to define the range for area 0 as well. So 10.100.100.0, 255.255.255.0. Okay, I'm going to define the range for that as well, because I carved out 4/30s in that subnet to build out my OSPF backbone area 0. So let's just take a look at the config now. And you can see that I have now defined the range of area 0, and I've now defined the range of area 1. Let's see how. Let's do a clear IP OSPF process. Yes. Okay, and we'll do the same thing on area board 1 if necessary. But I'm going to rerun the command again, and look what happens. You can see that I have just shrunk these 4 prefixes that was expanding my OSPF database, which was hindering the efficiency of my OSPF database table, into 1 prefix. And if I go into show IP router OSPF neighbor, OSPF, sorry, you can see that I am receiving 1 inter-area route for the 10.100.100 network, which is basically the /24, as opposed to receiving all the /30s. This is an efficiency mechanism that we deploy in OSPF to manage the database tables and manage the routing table as best we can. If we go into the Acme Edge 1, show IP route OSPF, the same thing happens. We have 1 inter-area route of the 172.16.32, all right? that is a /24 that essentially is representing all the /30s that are behind it. Okay, now what we're going to do is one more thing. We're going to go to area border router 3, so area border router here, okay, and we're going to announce out the VLAN prefixes, which I think is very important as well. So we're going to do show run ospf. Where's that command? Show run VN router ospf, and we are going to, just like we did in the previous videos, we need to announce out the network 188.16.85.0, 123.255 area 1. We need to do the same thing for 86, 87, and 88. Okay. Okay, now what we also need to do is we need to apply the passive interface for the exact same reasons that we described in the EIGRP series. We do not want to have OSPF adjacencies forming in the access layer, so as a security precaution, we are going to apply the following command. We're going to do passive interface gigabit Ethernet 0.285, 86, 87, 88, and that's it. And what that does is it suppresses the OSPF hello updates down to the access layer, but it also gives us the opportunity to announce out those prefixes into the area 1 domain. So show IP route OSPF, all right? So this has not changed, but let's go take a look at how Acme Core 1 recognizes that. And look, the same issue happens, the same problem happens. The area border router Acme Core 1 is recognizing every single VLAN subnet, okay, in its entirety. We need to be able to manage that. If we go into Acme Edge 1 and we do a show IP route OSPF, you can see that he's also receiving 4 LSA Type 3 updates representing the VLANs that are situated in the access layer to the left of your screen here. So what we're going to do is we're going to go back on Acme Core 1. And we're going to apply the range for the VLANs, okay? So we're going to go config T, router OSPF1, area 1 range, 188.16.80.0, 255.255.248.0, okay? Actually 240.0 represents the /20. I do apologize. So /20. So I'm going to end here. I'm going to clear IP OSPF process. We're going to let it sit for a second, and hopefully, all right, so we've just restarted all our adjacencies, and hopefully we've updated it. So if we go to Edge 1, for example, and I do a show IP, actually I should just do like that. Perfect. We can see now that all the VLANs, 85, 86, 87, and 88, are represented by one prefix, which is a /20, which means that I have the opportunity now to expand my network in this area. Okay, I can expand my VLANs as I please, okay, without affecting the efficiency of the OSPF routing upstream. Okay, so I can add as many prefixes as I want, because they will all be seen behind this /20, this /20 network. Okay, and it's represented. You can see this on Acme Edge 1. All right. Now, this is funny because this is the route that I made a mistake on, and it looks like I did not take it off. So let me just, that's very good troubleshooting. OSPF 1. No. I gotta take that off because it's not, see, this is technical debt that we have to remove. So we're going to clear IP OSPF process. I'll leave this in the video because it's good to see how these mistakes can happen. Okay, so we just clear that, and I'm going to recalculate, and then just give it a second for the LSAs to begin flooding the network, and we should see this come up relatively soon. Okay, and there you go. you can see that the /21 no longer exists and only the /20 is there. Now I want to focus our attention on Acme Edge 1 for a second because there's two very important points that I'd like to cover. So number one, we need to make note that an intra-area route will always be preferred over an inter-area route. Okay? An intra-area route will always be preferred over an inter-area route. Very clear. Secondly, I'd like for us to understand how this cost is calculated. You see, we haven't made any changes to the links or the OSPF links or the cost of these OSPF links. So if we calculate, okay, the cost of reaching this particular prefix from Acme Edge 1, we should get a cost of 3 because this is a cost of 1, this is a cost of 1, and this is a cost of 1. Therefore, 1 plus 1 plus 1 equals 3. So why is there 4? Now, this is the important point. Acme Edge 1 is the router that is receiving the LSA Type 3 update. Now, whenever a router receives an LSA Type 3 update, it adds not only to the cost of reaching the destination, but also the cost of reaching the ABR, which in this case is Acme Core 1. So again, whenever a router receives an LSA 3 type update, it adds the cost to reach the ABR to the cost of actually reaching the destination network. And that's the reason why you have 4 as the cost to reach 188.16.80.0. Very important point.